Today we're going to be talking about congruent and similar solids. So really a lot of it's going to be similar solids and what's their relationship between their scale factor and their surface area and their volume, all that stuff. So similar solids. Two solids are similar if they have the same shape and the ratio of their corresponding linear measures are proportional. So like, for example, if the ratio of the heights is the same as the ratio of the radii, or down here, if the slant heights was proportional to the heights. Now we're congruent if and only if, or no, congruent if the corresponding edges and faces are congruent. Said another way, their scale factor is 1. Here, remember, this is the scale factor. Scale, I think I completely spelled that wrong. Scale factor. Okay, so let's look at these pairs of solids and determine whether or not the solids are similar. So if we look at 2 root 3 to 5 root 3. So I looked at the length of these edges. Well, that is 2 to 5. Well, is that equal to 2 root 5 to 5 root 5? Yeah, that works out. That also equals 2/5. Now let's look at root 7 over 2. I can't write today because I'm focused on something else. I'm thinking about something else right now. Okay, I'm going to restart. I don't know why I keep writing root 2. Root 7 over 5, root 7 over 2. That's a 7. It wants to be a 2 today. So those 7s cancel, and you flip the denominator to bring it to the numerator. We got the same scale factor. So yes, they're similar. Our scale factor is 2/5. So now let's look at this one. So I have 6 is to 6. So our ratio, one of our ratios of our radii is 1. Now let's look at 15 is to 16. Hey, that's really close to 1, but that does not equal 1. So these are neither. Okay. Pyramid A, pyramid B. What I want you to do is I want you to pause the video and I want you to find the surface area of pyramid A. I want you to find the surface area of pyramid B and the volumes of both of these so that can help us with this. I'm going to write them in here in a minute, but right now pause the video. Find them out on your own to test to make sure you know how to find all of that stuff. And then I will give you those answers here in a minute. So for surface area of A, you should have gotten 384. For the surface area of B, you should have gotten, for the surface, I'm sorry, I'm doing this wrong because it's written wrong in my notes. For the surface area of B, you should have gotten for the volume of A, you should have gotten 384. And for the volume of B, you should have gotten 10,368. Let's look at these. What's so special about these? So let's look at 8 is to 24. Well, 8 divided by 24 reduces to 1/3. Let's look at another side. 10 is to 30. That also reduces to 1/3. 12 is to 36. That reduces to 1/3. So these are similar with our scale factor being 1/3. Let's look at the fraction of these surface areas. So the surface area fraction, 384 divided by 3,456. I reduce that in my calculator and I get 1/9. So the surface area ratio is the scale factor squared. Let's now look at volume. So we look at 384 over 10,368. And that is equal, what I simplified in my calculator, 1 over 27. Well, that is our scale factor to the third power. That was kind of the whole point of this, okay, is to show you that the surface area of two similar solids is going to be the scale factor squared, and the volume is going to be the scale factor to the third power, or cubed. So, again, this is what I talked about on the last slide. It makes sense to me because surface area is units squared. Volumes is units cubed. Okay, so our next example. Two similar solids have radii of 9 and 12 inches. What is the ratio of the volumes of the smaller cone to the larger cone? Okay, so I have 9 to 12. What does that reduce to? That reduces to 3 to 4. The ratio of the volumes, well, that's my scale factor cubed. So I take that scale factor and I cube it. Well, that is going to be 27 over 64. Or you could write it as 27 to 64. Okay. The two softballs shown are similar spheres. Find the radius of the smaller softball if the radius of the larger one is 1.9. So volumes here, okay? 9.15 pi over 4.06 pi is our scale factor squared. Well, first, realize we can cancel out the pi's. So I have 9.15 over 4.06 is equal to my scale factor. Okay, so 1.9 is one radius squared over the other radius squared. I apologize, not squared, because we're talking about volume. These are going to be the third power. So I cross multiply and I get 9.15 times 1 radius cubed equals, I do 1.9 cubed, I multiply it by 4.06 in my calculator, and I get 27.84754. So r cubed is equal to 3.043. And then remember, we cube root. So we get our radius to be 1.45 inches. And it's funny, the radius of I think there's a typo in here. I'm just looking at that. The radius of the larger one is just 1.9. That cubic inches shouldn't be there. Man, this is not a good lesson for me today. There's all kinds of mistakes. Okay, our last example. Hopefully I can get through this one. The surface area and volume of two similar solids is given. Find the volume of solid number 2. Okay, so 128 over 162 is equal to my surface area squared. I reduce this fraction in my calculator, and I get 64 over 81 is equal to my scale factor squared. I square root to get 8 over 9 is my scale factor. So remember, my volume is the scale factor cubed. So 8 over 9 cubed is going to equal 4608 over the volume of my other one. 8 over 9 cubed, I would let you guys use a calculator on that. We cross multiply and we get 512V equals, and again, this is a huge number. So again, calculators, you can use these. So I divide and I get my volume is 6561 and inches cubed. Okay, so that is my video on congruent and similar solids. Thank you for watching.